Hey everybody, this is written assignment number 8, question number 10. So the question is saying that triangle ABC is a right triangle with the right angle at angle A. So we know that this right there is a right angle. Okay, the question is asking for the length DC, this length right here. And that is denoted as x. So basically find x in this picture. Now, the most common mistake I will see is that people will say, well, look at that triangle. It has 14, 16, so 14 squared plus 16 squared equals x squared. Wait a minute, what is going on here? Now, if you were doing that, you would be using, or you might have been using the Pythagorean theorem, right? Now, the Pythagorean theorem is only applicable in right triangles. Okay, so if we look at this triangle here, it is not a right triangle, so that does not work. All right, so that doesn't work. We have to look at right triangles in order to apply Pythagorean theorem. So with this, we would say, well, let's take a look. There's the right angle. So you either have this big right triangle there. I'm going to go ahead and copy that over to here. Okay, you either have that big right triangle there, where this is the right angle. This is 10, this is 16, and this long length right there, part of it is x, but the length, the leg of the right triangle is more than just x. So let's call that A. All right. So, or you can look at the right triangle that is here, the orange one, the smaller right triangle that is here. Okay, so I'm going to go ahead and copy that one down. That one looking like this. Here's a right angle here. This is 10, this is 14, and this length we don't know. Let's call that y because x is already used. So let's call that y. Okay, so if we can find y and we can find a, then we can go ahead and be able to subtract and get x. So that's the plan. So with this orange triangle here, we would say 10 squared plus 14 squared is equal, oh no, that's not it. It has to be leg square plus the other leg square, which would be y square, is equal to the hypotenuse square, which is 14 square. So be really careful there. 10 square is 100 plus y square is equal to 196 minus 100 to both sides. Y square is equal to 96. And to undo square, we would have to take the square root of both sides. So here we say y is approximately, not sure what it is. Let's go find it. I have to use my calculator. If you haven't already, go ahead and bookmark Decimal Scientific Calculator. It's this guy right here. It's pretty awesome. Square root of 96 is equal to roughly 9.8. Okay, so let's go back to our question. 9.8, approximately 9.8. So that is y. Okay, now let's go and find A. Well, again, leg 1 square plus leg 2 square is equal to the hypotenuse square. That's what Pythagoras said. within a right triangle, like 1 square plus like 2 square equals hypotenuse square. So we have 10 square plus a square is equal to 16 square. 10 square is 100 plus a square is equal to 256 minus 100 from both sides. That is a square equals to 156. Now, in order to undo square, we would have to square root both sides. So a would be approximately 12.5. Okay, so a is approximately 12.5. Now, we know from the orange triangle, this part right here is 9.8. And this part right here is x. So x is equal to 12.5 minus 9.8. So x would be approximately 2.7. And that's how we found x. But the main point here is in order to use Pythagorean theorem, we would need a right triangle. Right triangle. Okay, now how do we know we need to use the Pythagorean theorem versus trigonometry? We have 2 lengths and we are looking for the third one. Okay, we have 2 lengths and we're looking for the third one. So that is Pythagorean theorem rather than trigonometry. Okay, trigonometry is when you have a right triangle like this, and you know an acute angle, say, I don't know, that one looks like it's 47 degrees, and then you do have a length, whichever it is. So let's say this one is 10. So if you know an angle and a side, then right triangle trigonometry would be the trick here. Okay, whereas if you know 2 sides and you're looking for the third, then it's Pythagorean theorem. And that is what I want to highlight in this problem. When to use Pythagorean theorem versus when to use trigonometry.